I'm going to talk to you, as Damian said, about maximizing the potential of documents, NLP, and AI at Seek, technical and non-technical challenges. Even though it might sound like I'm going to talk about some technical and some non-technical challenges, the reality is that actually all of the challenges we face are both a combination of technical and non-technical. And my goal here in this keynote is to kind of provide a bit of an insight into what it's like, an insider view of what challenges we face at Seek, what it's like working in industry on these types of problems. I'm going to use AI in the sort of industry sense of anything sort of machine learning related. And so I'd like you to sort of put yourself in the mindset of a data scientist working at Seek. So sort of imagine that you're working at Seek, or maybe think of some industry project that you're working on recently, and what sort of challenges did you face? I know that if you're part of my team, you might have one of these 4 ideas sort of floating in your head. One, how can we live up to the increasing expectations that people have for AI services? AI is in the media, it's very popular. Everybody has some preconceived expectations of what it means. And how can we deliver those services into production efficiently and confidently? How do we know that we're actually delivering value and we do this in an efficient way? Another challenge would be, how can we extend our AI services into new products, new markets, or new languages? Once we've built a model, that's just one challenge, but then how can we sort of get the most potential out of it by reusing it maybe in other contexts? And the 4th challenge is, how can we leverage the knowledge and resources that are spread across our large team? And probably not everybody has this challenge, but at Seek, we have hundreds of people in our AI team. And so this is a real challenge for us. And I call these challenges the expectations challenge, the delivery challenge, the expansion challenge, and the collaboration challenge. And all of these have non-technical motivations, the way that I've sort of framed them, but at least partially the solutions are technical solutions. So before I get into that, I did want to sort of say a little bit about myself. Damian already did a pretty good introduction, so I won't spend too much time here. But I did want to maybe convince you that I do have a fair bit of experience working with, you call it document computing or natural language processing in a variety of contexts, working with documents like 2,000-year-old papyri when I worked at the Papyrus Collection, working on the Petra Papyri at the University of Michigan and in Amman, Jordan, working in Dublin on headlines for the Irish Times and beef news for the Irish Farmers Journal. At ANZ, we worked with the Dow Jones news feeds to provide a news platform for credit analysts. And of course, at Seek, where I'm part of the AI artificial intelligence team, we work a lot with job ads and candidate documents like resumes. For the people who are in Australia or New Zealand, you probably are familiar with Seek. You may know that Seek is the leading job board in those markets. You may be less familiar with the fact that Seek is actually a global company operating largely in Asia Pacific, but also in the Americas with a number of different subsidiaries and investments. This plays into our challenges as data scientists, partly through being able to deliver products and services into all of these markets, and also in a sort of collaborative sense where I'm part of Seek, but I'm working every day with people from Seek Learning or CertC or JobsDB, JobStreet, Jora. This is a part of the collaboration that we do on a daily basis. And we're all working from home during the pandemic, but even before that, I was working with people who were joining us remotely from Sydney, Auckland, Brazil, Malaysia. So it's a global team, and Seek has a global presence. And that also means that we have an audience of 250 million candidates and 1 million hires worldwide. So Seek is an employment marketplace, and it's what we call a two-sided marketplace. So that would contrast with a one-sided marketplace, which might be something like Amazon. So Amazon has buyers and sellers, but if you go on Amazon as a buyer and you find a book that you want to buy, you sort of click the button and you buy the book. There's no risk that the book is going to say, oh, actually, I don't want you to buy me. But that's what happens in two-sided marketplaces, right? So both the buyers and the sellers have preferences. And in Seek's case, we have hirers who go on the site to post jobs and search through candidates. And the data that we collect from them mainly is in the form of job ads, but there's lots of other things as well. And then on the candidate side, candidates go on site to search or browse through jobs, to apply to jobs, and they might update their profile. And the data we're collecting from them is things like CVs, cover letters, profiles. And the marketplace part is, we're connecting candidates through their behavior to find job ads, but we're also connecting hirers through their behavior to find the right candidates for their jobs. So the AI team at Seek is called AIPS, AIPS. It's a large team, at least 150 people across the whole team, and we organize ourselves into smaller cross-functional teams, meaning that we have a mix in each team of data scientists, engineers, and product people. Each of those teams is focusing on a specific information problem, which is what we call it, and building AI services. And those services are things like job search. So if a candidate types in a query, we're going to show them the jobs relevant to that query. Job recommendations, candidates not giving us an explicit query, but we're showing them jobs based on their behavior and other users' behavior. Talent search is kind of the inverse of job search. So a hirer might come on site and they search through our database of candidate profiles to find relevant candidates. Recruiters also like to use this product. My team works on models of candidate job fit, which is essentially ways to identify who are the high quality candidates for specific jobs using machine learning. And we also have teams working on things like predictive modeling of job ad performance. It's a marketplace. We want to know if jobs are performing sort of above or below the expectations. We have a very large proprietary ontology and knowledge graph, which are maintained and developed by dedicated teams within AIPS. And we have a product science team, which does business BI and experimentation sort of for all of the cross-functional teams. And that's not counting data engineering, ML ops, governance, ethics, other sort of support teams that we have within the team. So today, even though all those things are very interesting, I'm going to focus on the things I know the best, which is my team, specifically these problems of talent search and candidate job fit. And so thinking back to this diagram, the problems that my team is specifically focusing on solving are helping hires to find the most well-qualified candidates for their role, and helping candidates to find and get offered jobs that they're well qualified for. So everything we do from a sort of a machine learning NLP perspective is trying to solve these problems for our users. And before I get into the challenges, I do want to provide a little bit of context about the data that Seek has, because that helps set the context a bit more. So the first piece of data is, of course, the job ad itself. This is, if you go on the Seek website, this is what you'll see. It's a mixture of structured and unstructured data. So the title for a job ad is actually unstructured. Hires can type anything they want in there. So in this case, they put technical business analyst 6-month contract. And a lot of times hires will put a little sort of extra irrelevant, or not irrelevant, relevant, but not the sort of title in the title. So if we wanted to do something, analytics perspective to sort of group all the business analyst jobs together, well, somehow we have to take this unstructured field and either normalize it or do some sort of entity recognition to say that this is a business analyst job. I'm going to group it with all the other business analyst jobs. Or actually, this is a technical business analyst job, and I want to group it with those. There's also some structured metadata. So this is the type of stuff that people select from a drop-down list. So the location and classification. So there's no ambiguity there about what the hire is intending to put there. But when we get to the job ad content, which is the bulk of the job ad, it's unstructured HTML. There's a lot of consistency to some extent about the ways that people write job ads. There's almost always going to be a section like about you or job requirements where they might put bullet points and say, these are the skills that you need to have. But of course, everybody is free to write that in a completely different way. So we have to use NLP techniques to sort of extract structured information from that unstructured field. And then also at the end of the job ad, you might notice the hire can ask screening questions. And this is actually a structured field because we have a curated list of questions. And for the most part, hires can't just ask any old question. They have to choose one from our list. The other side of the marketplace data is the candidate data, right? So there's two main pieces of data I'm interested in, the resume and the profile. So the resume is this unstructured document. It could be a Word document, a PDF. Those are the sort of typical things that people will upload. So we have to, from that, somehow extract the text and then do some processing, again, similar to the job ad. So this is my CV, and most CVs will have similar sort of fields, some contact information, your name, education, work history, experience, but everybody writes this in a slightly different way. So we do have to do a fair bit of work to try to extract that into a structured format. And then we also have on Seek a profile, which is where the candidate can provide more or less the same information, but in a more structured way. So if somebody puts something in their career history box, we know that that's a career history. We know exactly what the start and the end dates were, what the role title was. There's still a lot of unstructured information there in terms of what they actually put into those fields, but in a lot of ways, this is easier to work with. We also do sort of prompt users we extract things from their resume and then prompt them, nudge them to add that to their profile. But at the end of the day, we kind of have to rely on both pieces of data because not everybody uses the profile, and sometimes people don't upload resumes, although resumes tend to be more common than profile data. And then there are kind of two ways that in my team, we work with these documents. So the first approach is kind of a bag of words or more of a bag of tags approach, where the job ad or the resume goes through an information extraction process. In my team, we use the Spacey. We use a lot of open source tools. So in this case, we use Spacey for named entity recognition. We do named entity linking against Seek's custom taxonomy. And as a result of that, we might get a list of tags. So like if this job ad is for a nursing job, we might have tags like, do you have an APA registration? Do you have good communication skills? Do you have critical care experience? Or do you have a CPR certification? And then some of the products we can build off those tags are things like, for a candidate, they might be interested in starting a career in nursing, and they might say, well, show me what are the skills I need to start a career in nursing? And so Seek has career advice pages. You can go there and you'll see these tags coming exactly out of the system that we use in my team. We do the similar thing on the resume to extract tags, and this can be used for products like if candidates filling out their profile, we might nudge them to say, well, you mentioned this in your CV, do you want to add it to your profile? Or maybe you mentioned these skills, but you didn't mention this other one that people similar to you mentioned, and you can add that to your profile. And if we take the job ad and the resume tags together, then we can start to sort of match up how well does a candidate match to this job ad. And we can use that for products for hires to say, show them who the candidates are that satisfy the job requirements they put in the job ad. So the second sort of complementary approach is more of like a language modeling, deep learning approach, where we can take the same unstructured text inputs from the job and the resume, but instead of doing a bag of words information extraction sort of approach, we use an embedding approach. And for this, we use open source libraries. A lot of people will be familiar with the Hugging Face library. So we can use pre-trained language models from Hugging Face, adapt them to our data and our use cases. And then we get vector representations of job ads, vector representations of resumes. We do something with those resumes, and then we can solve problems for the candidate and the hire, like showing the candidate all the jobs they're well qualified for, or whether they're well qualified for the job they're looking at. Or for the hire, we can say, show them a list of candidates who might be a good fit for the job that they're advertising. And this works well in sort of classification type of scenarios where you just need a kind of a yes/no answer, but it works a little bit less well when you need to explain what's going on, because with black box models, we all know that they're kind of difficult to explain. So that's the context for my team at Seek and the types of data that we're working with and some of the techniques that we use. And so I'll spend the rest of the talk talking about those 4 challenges that I mentioned. And the first challenge I want to talk about is the challenge of expectations. So how do we deliver on the high expectations that we set and that others have of our services? So at Seek in AIPS, we have high expectations of ourselves. We only want to deliver products that are high quality and trustworthy AI services. So those are our own expectations, but there are also other people involved who have their own expectations. And these could be the data scientists who are working on the product itself. We have partners and stakeholders within Seek who have different expectations. And then we have users and the media and government and all these people outside of Seek who have their own perspectives and their own expectations. So if I start with my own expectation as a data scientist, I'm very close to the problem, very close to the data, and I understand, you know, the current state of the data and the models that we have. And I also have realistic goals for how we can improve those services, what our ambition is for the next iteration to do even better. And then also, I have a realistic concern about the potential biases and harm that could be, you know, in these models. And that enables me to sort of exercise caution around the services that we're developing. But as you get sort of further away from that, we have partners and stakeholders within Seek who might be less familiar with the techniques and the data and the reality of the situation, but they're reading the news, they're talking to their friends, and they might have unrealistic expectations about AI performance, and they might be a little bit more into the hype than the reality, which means that as a data scientist, I kind of have to communicate that if we're building this model, you know, it's not going to be 100% perfect all of the time, and I have to explain what, you know, precision and recall are and things like that, and why the model isn't perfect all of the time. The flip side of hype is sort of paranoia, that people are also reading the news and hearing about all of these potential harms of AI and ethical issues, and you know, they might be overly concerned that our models are doing something really harmful. And you know, those people don't see what I see, which is all the steps that we're taking to sort of mitigate those fairness and bias questions. A couple of the ways that we deliver on the ambition part of this expectations is we do innovation within AIPS. We try to set aside time to explore new ideas and new technology. And we also have a dedicated product science team that ensures that the only models that ever make it into production are ones that have been tested and that we're confident benefit Seek's users and also benefit the business. And the way that we address the potential bias and harm of our models, AIPS has been on a journey over the past few years of implementing AI principles and a whole AI ethics framework within AIPS. And so one small part of that is we have defined what we consider our trusted AI principles, that all of our services should be beneficial, fair, transparent, defendable, reliable, and compliant. And I'll talk a little bit later about some of the things we do to live up to those principles. So with that first part of, you know, delivering on our ambitions by innovating in the AI space, a few things that we do at Seek are actually some of the things I really enjoy about working at Seek. So there's the Seek Hackathon. Last year we had hack number 16. So I expect that the hackathon is something that's been going on for 16 years at Seek. If you look at that graphic there, it gives you an indication of how sort of polished this hackathon is. Everybody in the business gets involved. It's not just tech people, it's not just AI people. It's a great opportunity to collaborate with people across the business. In fact, one of the models that my team owns actually was born out of a hack project maybe 4 years ago. Another thing that we do is within the AI team, on a more frequent basis, we have what we call innovation weeks. So every couple of months, we'll set aside a week to work on innovation projects. So this is an illustration of a Miro board where everybody has dumped their ideas of what they want to work on. It's pretty impressive, the number of ideas that we've been able to go through in these innovation weeks. And these are good opportunities to try, you know, new model architectures, new software libraries, or even a completely new idea for how we might use our data or our models. Actually, one of our recent innovations in my team was we built a UI to explore some of our models and their predictions that we actually deployed internally, and now we can share it with some of our partners within Seek, which helps a bit with the explainability and transparency about the services that we're building. The third thing that I wanted to mention is applied research. So Seek doesn't have a dedicated R&D team, but we do have a long history of working on collaborative research projects. I think several of the people in the audience here would be familiar with some of those projects. And Seek supports this. We try to support people to do research, and also just to be connected, stay connected with the research community, attend conferences, or even this, I suppose, would be an example of that. More on the fair and transparent AI services side. This is a major concern for Seek. It's probably a concern for lots of industry companies working in AI. There are a lot of challenges. It's a complex space, but there are some concrete steps that are fairly easy for us to take. And those are at the bottom. These are things that we've implemented on my team. Across all of our services, we do ethical assessments of our services against those different principles I mentioned earlier. It's a pretty comprehensive process just to make sure that there are that we've checked everything in the data, in the model architecture, and convinced ourselves that the risk of bias in this model is fairly low. But on top of that, we also do some concrete measurements of fair and transparency metrics, both at the model training step and also after the model's been deployed. We do model monitoring to make sure that nothing is changing since the original deployment. But of course, that doesn't necessarily solve these some more fundamental kinds of questions that are still sort of bubbling away. Like, what are the risks associated with pre-trained language models? We know that pre-trained language models can have bias in them. We do things to try to mitigate that, but are we sort of covering all of the potential problems there? Defining fairness is actually a very difficult thing to do, and kind of in a mathematical sense, it might be impossible to be fair in every definition of fairness. We know that we want our services not to be biased against groups of people, based on things like religion, ethnicity, sexual orientation, gender, and things like that. But in order to measure that, we have to know that. And Seek does not, when you sign up for Seek, we don't ask you what your religion is or what your gender is. So do the risks of trying to collect and curate that data outweigh the risks of having a service that might be biased against those people? It's a challenge. There's a general sense that transparent models are not as high performing as black box models. And of course, we also have to, in all this, balance the interests of multiple parties. We're a multi-sided marketplace. There are a lot of angles to consider. So the next challenge that I want to talk about is the delivery challenge. So how do we efficiently deliver improvements to our services in order to provide the best user experience and the best value for Seek? So for this, I'm going to use an example of a service that my team is working on for talent search, which is an existing service. Hires can go on Seek and type in some keyword searches, and they'll find the profiles and resumes for candidates who match those searches. Our idea was to improve on this experience by adding in a component of the quality of the candidate, which we incorporate through one of our machine learning models, which predicts the probability that a candidate would be shortlisted for a given job. So based on some of the data that Seek collects, we have sort of millions of data points to train a model like this. And it uses this kind of language model embedding approach that I described earlier. So we have millions of resumes. All of those go through our embedding model and get stored in a database that can be searched. And then when somebody posts a job ad, we treat this as a query, and the job ad is encoded into a vector representation. And we use just a sort of standard elastic deployment and use an approximate k-nearest neighbors algorithm to find the best matching candidates for that particular job, which for the hirer, what they see is a service where they post a job and we show them, here are 10 people that we think are a good fit. Maybe you want to invite them to come apply to your job. And as I mentioned, these vectors are not sort of your standard BERT transformer embeddings. They've been tuned and trained specifically so that the dot product is an approximation of this probability of shortlisting. of course, like that's the idea of the service, but then there's also a question of, well, how do we get from this idea to actually having something in production? And like, I think pretty much any other team you'd find in industry, we use an agile sort of approach. I like to think that we do what you could call lean data science in order to deliver MVP services. So in this case, the first step was a naive implementation of this idea. So we reused some models that we already had for other services. We restricted our feature set. We used a sort of standard off-the-shelf Elastic deployment in Amazon Web Services just to validate that this actually worked. At that point, we realized we were spending about $300 a day on this Elastic cluster, which isn't a ton of money, but it might be more money than you want to spend on a proof of concept that isn't actually providing any value to users. So we spent a little bit of time in the engineering team implementing various optimizations to reduce that cost. And at the same time, automating the processes we have for deploying the model, evaluating the model. You can imagine the process of encoding 10 million resumes and indexing them into our Elastic instance. That all being automated enabled us to move on to another stage of iteration, focusing on refining the model itself. So we collected some more data so that we could get a better sort of evaluation view, added a few more features to the model, fine-tuned those models, and we created a visualization or sort of a simple UI for the results, which enabled us to then take this out to people both in Seek and hires who use Seek through interviews to get their feedback about the quality of the results that we were producing. And that sort of got us to the point where we felt like we had a good enough service. And I think the idea of lean data science should be that you deploy as soon as you have a good enough service, not before that. There's a lot of work that went into getting, something that was actually, we were confident was delivering value, but we want to get to market as quickly as possible. So we're taking this model, deploying it into production in order to run experiments to prove that actually, in fact, it does provide the value that we think it will provide to the users. That deployment process of A/B testing or experimentation is actually run in AIPS by a dedicated product science team. So the various cross-functional squads that I described, each of us is working on a specific problem domain. We get the data, we implement new algorithms, we deploy those as services. We define what we think the business metrics are that we're going to be able to improve with this new deployment. And we'll also do an offline analysis to convince ourselves that the model is being trained properly and maybe estimate what we think we might see in those business metrics, but sometimes that can be challenging to replicate. If you're not actually putting this in front of users, it's hard to anticipate what the users are going to do with the outputs that your model is producing. And then the product science team comes in to sort of build this end-to-end experimentation. So they'll design the experiment, estimate the runtime that we need to get a p 0.5 significance result, and they have a experimentation platform that they've built in-house to run these experiments, to track the results, to analyze the results, and to give us an answer at the end of the test. So, for example, in this case, we might send half of hires to one experience, the other half to the oldest, to the older new experience, measure the metrics that we're interested in, and then hopefully what we see is that the new algorithm, the challenger algorithm, actually outperforms the old algorithm. And that brings us to the third challenge I wanted to talk about, which is the expansion challenge. So how do we extend our services into multiple markets in multiple countries in multiple languages? There are a lot of questions here, and some of them don't have clear answers. But the general idea is, if we've put the effort into building a machine learning model and we know that it works well, it's in a service that's delivering value to users in one market, why wouldn't we want to take that to users in other markets as well? So if I build a model and it's working really great in Australia, maybe I could take that same model and deploy it into New Zealand and expect to see a good result there. Actually, what happens a lot of the times is we'll actually deploy it first into New Zealand, which is a smaller market, and then deploy it in Australia. But that works well enough because Australia and New Zealand are fairly similar, and they are majority English speaking markets. But that's omitting the fact that in New Zealand there actually is a small but significant minority of jobs that are posted in Maori language. And if you go to other countries like Indonesia or Thailand, that's even bigger. So in Indonesia, I think half of the jobs are in English and the other half are in Indonesian. So in this case, your Australian English language model isn't going to work, or it's only going to work for half the market. And even if the language part sort of matches up, Australian certifications and licenses are not the same as Indonesian's licenses and certifications. So there are definitely differences related to those markets. And so the question is then, well, how many models do I need to build? Can I build one model that works in all these scenarios? Do I need 3 models, one for each language? Do I need 4 models, like one for each market? Or do I need 6 models, like one for each combination of market and language? And if I'm going to build 6 models, I really don't want to go through the effort of starting from scratch each time and, collecting all the data that I need, experimenting with different models, writing the model training code, building that into a deployment infrastructure. So instead of replicating the same work 6 times, and in the reality it's going to be a lot more than 6 times, what we try to do is sort of write it once and deploy it multiple times. And this is where a lot of the work that my team's been doing over the past year or so on MLOps comes into play. We now have very good model training pipelines, which we use Metaflow to organize the model training code, which runs a TensorFlow training process. We deploy everything. We use GitHub repositories to store all of our code, and then we use BuildKite for the build process to deploy it. And we use Python as a sort of lingua franca in the team, which means that data scientists and engineers are able to collaborate together, and we don't have, which is something that was the case in the past, where data scientists were using Python to train models, but then the engineers were exporting the models and deploying them into services written in Scala or something like that. And so all of this means that we have a pretty good sort of integrated ecosystem to train, evaluate, and deploy machine learning models, which enables us to then scale up. And of course, there's a lot of extra work there in sort of configuration and hyperparameters and models and things, base models, et cetera. But this is the general approach that enables us to address this expansion problem. And yeah, as I said, there are of course challenges. So even if we have all of the data, that data is coming from different systems, sometimes potentially even different user experiences. Different sites in different markets have different experiences. So even though it looks like the same data, it might have some differences. For example, what do resumes actually look like in that market? So if I'm in Australia, I don't put my date of birth and my marital status and my religion in my CV. But in some countries, that's a standard thing. And if you have all that information at the top of someone's CV, does that mean that your model is going to learn to hone in on those features and potentially train in some bias? It's definitely something we have to be looking out for. Of course, if we're going into different languages, then of course we have different challenges. I mean, I would much rather download a Thai tokenizer that someone else has built, so I don't have to go through that effort myself. But I still have to validate that it actually works. It works well enough that I have confidence in it. There are a lot of pre-trained language models out there that you can get, but you have to, again, treat that with a little bit of caution as well. And then, again, going back to the sort of user experience and the behavior, like it might be that hires in some markets just don't behave the same. A simple sort of illustration of this is when we collect information about who's getting hired or rejected for a job, if in one market that might be 80% of people get rejected and 20% get hired, and another, it might be 50-50 or 90-10 or that sort of distribution. And that's not specific necessarily to the countries, but like lots of different definitions of what a market might be. So these are all the sort of things that we have to keep in mind. And at this point, if you're starting to think about these challenges and think that they sound interesting or hard or the type of thing that you'd like to work on, I am going to make an appeal at the end to come work for us at Seek as well. So the last challenge I want to talk about is the collaboration challenge. So how do we share knowledge and resources across this large team as it continues to grow in sort of an efficient way? So this is an illustration of how I see our organization within AIPS. So as I mentioned, we have cross-functional squads, so the horizontal bars. So each squad focusing on a specific information problem. Like I said, my team focuses on this candidate job fit kind of problem. And then within each squad, there's a mixture of data scientists, engineers, and product people. But then across all of these different squads, we have people who have common interests or working on similar problems. And if you spend all of your time just working with your squad teammates, you don't get those opportunities to learn and benefit from lessons that other people in other squads might have learned. So one of the solutions to this is what we call guilds. So within the data scientists, every couple of weeks, all the data scientists in Seek will get together in what we call the Data Science Guild. We bring in external speakers, we do internal presentations, we do brainstorming sessions where we just sort of talk about what we're working on. And that's one way that we sort of, if one of the squads has been working with some technology and they learn something good or bad about it, they can share it with the rest of the team. We also have guilds for things like there's a natural language processing interest group, ML ops interest group, data engineering interest group. And of course, this diagram is a bit of a simplification. Even though I'm a data scientist, I'm still interested in ML ops, and I'll go to those talks and things like that. And that's like a non-technical component of the solution. But even though this is a very non-technical problem, there are some technical solutions that we can bring to bear. And one that I think I'm very excited about is our private PyPy repository. And this is a pattern that we've landed on within my squad, where every time we build a new machine learning model or a new AI service, we build it and deploy it as a Python package. So you could see here in this illustration, you might have squad A and squad B are working on different models. They might even be using different libraries, like maybe one of the squads likes to use PyTorch and the other one likes to use TensorFlow. That could be a hindrance to collaboration, but actually if you go through this process of packaging, building, and deploying your whole service as a Python package, and we use the Poetry, which is a library that makes it very easy to do the dependency management and to publish your packages to a private PyPy repository that we've set up inside of Seek. Every time you build that project, it releases as a new version in PyPy. And then different services that depend on that model, that need that model, can just pull the Python package out of the PyPy repository. So if we build a machine learning model, we want to deploy it in an API. Well, that's two processes. We train the model, we publish it to PyPy, and then we have an API that all it has to do is pull the latest version and serve it as an API or as a AWS Lambda function. And if there's another squad that wants to do something with our model, it's just as easy for them to go and pull that Python package and run it themselves. So this enables, it partly enables cross-squad collaboration, but it also really enables a lot of the services that we need to do as a regular part of our work. And it's a fairly new thing that we started doing, but it's been very promising, very successful so far. So that's pretty much the end of what I wanted to say. These 4 challenges that we're working on, and I did want to finally sort of end with a bit of a message about what it's like working at Seek. Basically, I think it's great. Seek is a very nice company to work at. Part of that is the fact that you're building models and services that really benefit people, millions of people. Finding the right job is something that's very impactful and very important for people's lives. So by helping people find those jobs, it might be something that's satisfying to you to say, I've actually had a positive impact on people. Also, working on AI in Seek, I mentioned we're a large team. There's a lot of internal support, and that's a very important thing as well, to know that the whole business is supporting you. And working as part of a big team, there's 120, very nice, very diverse, very smart, friendly people for you to have lunch with, and also to work with, to learn from. There's always a feeling that you're supported, and if you have questions, there are lots of people that you can ask who are going to be willing to answer them. And it's a great opportunity for just development. To be around people who know what they're doing that you can learn from is a really good thing, I think, in a workplace. And Seek's been voted the #1 best place to work in Australia 2021. I think that's well deserved. If you're interested in opportunities at Seek, check out our website. And also, I'm very happy if anybody wants to contact me directly. So I'll just close by saying, I've showed you an example of challenges that we face at Seek. All of these challenges have a mixture of technical and non-technical components. If you're working in industry, there's no such thing as a purely technical problem. And even though these are specific challenges that we're facing at Seek, I suspect that other companies probably have similar problems. And so I think this is potentially applicable not just to Seek, but more generally. And I'll close again by saying that we're growing at Seek. It's a great place to work. If you have any questions about what it's like to work at Seek, feel free to reach out. Thank you very much for listening. My name again is Terry Szymanski. There's my email. And I think maybe we have time for a question or two.
Yeah, thank you very much, Terry, for the great presentation.